talk about 3.4, the properties of logarithms. Now, logarithms have special algebraic traits that historically made them indispensable for calculations and that still make them valuable in many areas of applications and modeling. In section 3.3, we learned about the inverse relationship between exponents and logarithms and how to apply some basic properties of logarithms. We're now going to delve deeper into the nature of logarithms to prepare for equation solving and modeling. Now, some of the properties that we're going to be talking about today are the product rule, the quotient rule, and the power rule. So if we have log of r times s to the base b, that would simply be log of r to the base b plus log of s to the base b. If we had log of r divided by s to the base b, that'd be log of r to the base b minus log of s to the base b. And again, with this power rule, the last one, I've talked about this in previous videos, this power will simply come out to the front. Now, the properties of exponents to the left or below are the basis of these three properties of logarithms. For instance, the first exponent property listed is used to verify the product rule. So remember, if we're taking a power and multiplying it by a power, so b to the x times b to the y, they have the same base, so we can just add our exponents. If we're dividing, again, we're going to subtract our exponents. If we're taking a power to a power, so b to the x to the y power, we'd multiply our exponents. These are properties of exponents that we've seen before. Now, in example 1, we need to prove the product rule for logarithms. Okay, so the first thing I'm going to do here, I'm going to let x equal log of r to the base b, and we're going to let y equal log of s to the base b. That means then that b to the x power is equal to r, and b to the y power is equal to s. Now, we also know then, because we want to get r times s here, r times s will equal b to the x times b to the y. And going back to the property from the previous page, b to the x times b to the y would be b to the x plus y. So this is what we have. Rs is equal to b to the x plus y. Switching this back to logarithmic form, we would have log of rs to the base b is equal to x plus y. But since x is log of r to the base b and y is log of s to the base b, we can simply write this as so. Therefore, we did just prove the product rule for logarithms. Now, when we solve equations algebraically that involve logarithms, we often have to rewrite expressions using properties of logarithms. Sometimes we need to expand as far as possible, and other times we need to condense as much as possible. The next three examples, examples 2, 3, and 4, illustrate how properties of logarithms can be used to change the form of expressions involving logarithms. So example 2. What we'd have here, we can simplify this to log of 8 plus log of x plus log of y squared. Now we're going to keep going on this and simplifying. 8 can be written as 2 to the third power. Log of x can't change. And we can change log of y squared to 2 log of y. Oops. I don't know where I got 2 from. It should say 4 right here. Going a little bit further, we go 3 log of 2 plus log of x plus 4 log of y. And that would be your answer. Moving on to B, this is a natural log form. So what we can do we'd have something like this, change the square root into a 1/2. So what I can have is natural log of x squared plus 5 to the 1/2 power minus natural log of x. Going one more step, I bring the power down to the front. And there would be your answer. Now, I can't do anything with the x squared plus 5 because there isn't an, I'm not multiplying or dividing. That's the only time you get adding in there. Moving on to C, again, I would bring the 5 out front. So I'd have 5 ln of x minus, actually I don't want to do that at all. I want to condense this one. Because I have two natural logs, I want to condense this. And because I'm subtracting, I'm going to divide. So really I'll have this here. Now combining this, I'd go like this. Because I'm subtracting, I'd really be dividing, which means I'd have ln of x to the third over y squared. There are 3 more x's on top than there are on the bottom. Now, as we've seen, logarithms have some surprising properties. It's easy to overgeneralize and fall into misconceptions about logarithms. Exploration 2 should help you discern what is true and what is false about logarithmic relationships. Now, what I'd like you to do, I'd like you to turn off or pause the video, go through 1 through 8 of Exploration 2, and actually solve them. Now, you should have had ample time by stopping the video to answer these questions. Now, of the 8 relationships suggested here, 4 are true and 4 are false. Thinking about the properties of logarithms, make a prediction about the truth of each statement, then test each with some specific numerical values for x. Finally, compare the graphs of 2 sides of the equation. Let's just go through here. Let's check to make sure your answers are correct. First one, we cannot do what they did here. The only time we could do that is if we had x times 2. So the first one would be false. In the second one, that would also be false because the only time that you can bring the 7 out front is if it were an exponent. So that is false. Now if you look here, log of 5x to the base 2, we can separate these by adding. So the third one is true. The fourth one is also true. That's one of the basic properties. That is a quotient rule. And the fifth one is not true at all. That is not one of our properties. The sixth one is a property. We're bringing the power out front. The seventh one, this is log of x squared to the base 2. Again, we would simply bring this here. So this is false. And the last one would be true. And if you count them up, we've got 4 true and 4 false.